The center of galaxies holds some of the most mysterious objects in the universe. Black holes, the most massive objects in the universe. And at the top of the black hole hierarchy are ultramassive black holes, or UMBHs, with more than 5 billion solar masses. UMBHs are rare, and their origins are unclear. But now, astronomers have used simulations to uncover the formation of these massive objects. The simulations were carried out on the Frontera supercomputer, one of the fastest in the world, using the Astrid simulation. The simulations showed that UMBHs can form from the merging of smaller black holes, as well as from the direct collapse of massive gas clouds. These new insights into UMBH formation could help astronomers better understand the evolution of galaxies and the role of black holes in shaping the universe. The universe is full of mysteries, but with powerful simulations and cutting-edge technology, we are slowly uncovering its secrets. As astronomers continue to study the universe, they have discovered some of the most massive objects known to exist, ultramassive black holes or UMBHs. These massive objects are estimated to have over 5 billion solar masses and are incredibly rare. The origins of these massive black holes have long remained a mystery, but astronomers have recently made significant progress in uncovering their formation. According to recent studies, UMBHs are believed to have existed during the cosmic noon period, which occurred around 10 to 11 billion years ago. During this time, the universe was in a state of rapid star formation, and galaxies were colliding and merging, leading to the formation of massive black holes. Astronomers have been using simulations to study the formation of these massive objects. One such simulation is the Astrid simulation, which was conducted on the Frontera supercomputer at the University of Texas, Austin. This simulation has provided crucial insights into the formation and growth of black holes during the cosmic noon period. Overall, the study of UMBHs is an exciting field that has led to groundbreaking discoveries about the formation and evolution of the universe. With continued research and technological advancements, we can expect to learn even more about these fascinating objects and their place in the cosmos. The team of researchers from the University of Texas, Austin, used simulations to study the formation of ultramassive black holes, UMBHs, and found that they are most likely to form from the extreme merger of massive galaxies during the epoch of the cosmic noon. This period, which occurred around 10 to 11 billion years ago, is considered the peak of star formation in the universe. The team's simulations suggest that during this time, massive galaxies were more likely to merge and form even larger galaxies, which then had the potential to host UMBHs. The researchers used the Astrid simulation on the Frontera supercomputer to model the formation of UMBHs in these massive galaxies. They found that the extreme merging of massive galaxies can create a dense environment, leading to the rapid growth of black holes at the center of the galaxies. This study sheds light on the origins of UMBHs and provides new insights into the formation of massive galaxies. By understanding how these massive objects form and evolve, astronomers can better understand the structure and evolution of the universe as a whole. To further investigate the formation of UMBHs, astronomers used the Astrid simulation on the Frontera supercomputer at the University of Texas, Austin. The simulation showed that UMBHs could form from the merger of massive galaxies during the cosmic noon, a time period around 10 to 11 billion years ago. According to the simulation, 3 UMBHs assembled their mass through an extreme and relatively fast merger of 3 massive galaxies. Each of these galaxies was 10 times the mass of the Milky Way, with a supermassive black hole in the center of each galaxy. This merger resulted in the formation of a single UMBH, with a mass of more than 5 billion times that of the Sun. This discovery provides crucial insight into the elusive origins of UMBHs. It suggests that UMBHs are not simply the result of a gradual accumulation of matter over time, but rather the extreme result of galaxy mergers. This process could explain why UMBHs are so rare in the universe. The Astrid simulation is a significant milestone in our understanding of the universe's evolution and the formation of massive objects like UMBHs. It is an important tool for astronomers to study the formation and evolution of galaxies and black holes, and it could lead to more discoveries in the future. The simulation also revealed that opportunities for the formation of UMBHs from triple quasar systems are decreasing as the universe ages. This means that UMBHs might be rare objects in the present-day universe. The team concluded that the formation of UMBHs is heavily dependent on the availability of merging galaxies and the presence of massive black holes within them. With the ongoing advancements in astronomical observations and simulations, astronomers hope to learn more about these enigmata. See objects and unravel the mysteries of their formation and evolution. With the formation of UMBHs from the merger of massive galaxies, the resulting post-merger UMBHs approached the theoretical upper mass limit for black holes at approximately 50 billion solar masses. This limit was determined by astrophysicists, and the UMBHs are pushing the boundaries of what was previously thought possible in terms of the mass of a black hole. It is fascinating to think that these ultramassive objects are the result of galaxies coming together in the distant past, during the epoch of the cosmic noon. As our understanding of black holes and their origins continues to evolve, it is exciting to think about what other mysteries of the universe they might help us unravel. In conclusion, the recent simulation by astronomers has uncovered the formation of ultramassive black holes, UMBHs, which are the most massive objects in the universe. The study traced back UMBHs to the universe's cosmic noon, around 10 to 11 billion years ago. The simulation suggests that the extreme merger of massive galaxies during that epoch is one possible formation channel for UMBHs. However, opportunities for triple quasar systems to merge and form UMBHs are decreasing. The post-merger UMBH approaches the theoretical upper mass limit for black holes. Further observations are required to confirm these findings, and the James Webb Space Telescope, JWST, may help in unraveling some of the mysteries surrounding UMBHs. The authors conclude that the rare events of multiple massive galaxy mergers happening around Z2, the epoch when both star formation and AGN reach their peak activity, can give rise to ultramassive black holes with extreme masses of 50 billion solar masses.